Example 3.5. Determine the voltage Vx and the power of the 8-volt source using node analysis. So before we start the counting, we got to figure out the ground. So before we start counting nodes, need to choose the ground. So there are multiple choices. One choice is that I could choose this as my ground down here, right? So I could make this my ground. And why would I want to choose the ground? Because note that there's a 4-volt connected to it. And I could connect the 8-volt to this thing. Another ground that you could choose is that you could choose this one. And again, this is also a good choice because I have sources connected to the ground, just like the blue. And the other way that you can do this is that you can also choose this as the ground right here. This is also a good choice because it's connected to those 8-volt source and therefore the 4-volt source here. The way I'm going to choose my ground is that I'm going to choose the black one. So my personal choice, my choice is the black ground. And the question is, why would I choose the black ground? Okay, so now that I've chosen it, let's go do the numbers so you can see what I'm talking about. So here we go. So now I'm going to go to step 1. And I'm going to say, let's do the numbers. And so when I go do the numbers, what I'm really asking is that the question asks for Vx and the power of the 8-volt source. But what is the power of the 8-volt source? Well, it has to be the voltage of the 8-volt source times the current of the 8-volt source. But I already know what the voltage is, so that has to be 8 times I, 8 volts. So you're going to see here is that this guy and this guy right here are not going to be part of my nodes here. Because if I look at my circuit here, note that Vx is not one of the node voltages. It's the voltage across the 2 ohm resistors. So that's not going to be a node. So that means this guy is going to require a solver equations. Okay, so now that I have that, now I'm going to go label my nodes. So here's my first node. And then here's my second node. And so that means I'll call this guy V1, V2. And then we've already said that this is my choice for my ground. And now because I chose that ground, note that this automatically means here that this guy is, of course, 8 volts. And because I chose the ground there, this means that this guy right here is going to be -4 volts. So you could see that the number of unknown nodes is really this 2, V1 and V2. So when I start to do my numbers here, I'm going to see that I'm going to have what? I'm going to have 4 nodes, but I have 3 voltage sources, right? The 8, the 4, and the 6i. And so that gives me just 1 node equation. So when I look at this 1 node equation, we could see here is that because the 6i voltage source is not connected to the ground, we see that this is a supernode. So then if I start the counting here, then I have this. I have my supernode between 1 and 2. So that means I'm going to come in here. I'm going to do this. So my supernode goes like this. There's my supernode right there. Then, of course, I have a supernode condition. And then when I look at my DC, I said my DC here is going to be I here, because that's what the source did. Looks at this. But let's look at this thing a little bit more careful here. If I chose the ground to be 0, I mean the black one, note that V2 and I are deeply connected here. So if I focus on the V2 node, we see here that what happens here is that this guy tells me that V2 minus 0 must equal 2I. So in other words, I can eliminate I using I as equal to 1/2 V1. So if I do that, then I don't need a DC equation. So all I do is wherever I see I, I'm going to write 1/2 V1. That's why I chose the ground where I did. And then I'm going to need 2 solvers. I'm going to need 2 solvers, one for Vx and one for I8V. So when I do all my counting, you could see here I'm going to have 4 equations, 4 unknowns. So my unknowns are V1, V2, Vx, I, 8 volt. So let's go do that. So now I'm just going to start writing my equations here. So here we go. So my first equation is going to be my supernode between 1 and 2. So if I look at node 1, I only have 1 resistor. So this is going to be 1/2 V1 minus 1/2 8. And that's my first node. Then my second term here is node V2. There's only 1 resistor connected. So then this should give me 1/2 V2. And then I'm looking at the sources. You can see that there's only 1 current source and it goes into V1. So therefore, I'm going to get +4 right here. And this is node 2. Now, there's lots of ways. So this is not in matrix form yet. And the reason why it's not in matrix form is look at that 1/2 8. So if I take this to the other side, I'm going to write it like this here. So I'm going to get 1/2 V1 plus 1/2 V2. And then I'm going to add 1/2 8 plus 4, which then gives me 8. So that's my supernode equation right there. So then if I go to the supercondition, I'm going to find that my supercondition is going to be the high, which is V2, minus V1. And that's a source here. So this has to be what? Equal to 6I. But we said that wherever I see I, I'm going to replace this with 1/2 V2. So then this guy really reads 3 V2. So now if I rewrite this, I'm going to take everything to the right. So then all of a sudden, if I take everything to the right here, you see that one of the V2s is going to subtract. And this gives me 0. So that's my supercondition right there. So now I need my solvers now. The first solver that I'm going to get is the one for Vx. And you can see it's the difference between 2. It's the 2 volt or the 2 ohm, excuse me. So that has to be V1 minus 8. And then if I put it into matrix form, I'm going to take the Vx to the other side. And this should be equal to 0. But I would prefer to write it into matrix form. Right there. And then my last solver is for the current of the 8-volt source. So what I need to do here is that if I want the current, I have to apply KCL to the blue node. So I'm going to apply KCL to blue node to get that current. So let's draw it out. So I have my resistor. I have another resistor here. And unfortunately, these guys have the same resistor value. So I'm going to change how I write this. So this is the red node right here. And I know that this guy right here is the 2 ohm. And this guy right here is Vx. And then right here, I have a 2 ohm. And then, of course, here's my 8 volts. So I'm going to just think about how I'm going to set up my directions. So I'm going to assume that the current is going to be flowing in this direction. So this current I'm going to call I 2 ohm. Now I'm going to guess now, because this guy right here is minus 4. And this guy right here is 8 volts right there. I'm assuming that the current has to go down this direction. I don't assume, I know. So then this is going to call I, but because there's 2 of them, I'm going to call that I prime. So now I got to pick a direction for this current. And what I'm going to do here is that I'm going to assume that the current of the 8-volt source is going to go like that. So now I have my KCL equation. So now if I look at my KCL equation, it looks like this. I have KCL, then tells me that the current in has to be the current of the 2 ohm. The current out has to be I 2 prime ohm plus I 8 volts. So then this tells me here, if I start to put everything in here, I'm going to get, this is going to give me what? So I2, well, I know that that's the voltage of this guy. So you know what? I'm going to bring that 2 ohm to the other side. So here I go. So I'm going to have, so if I bring this to the other side, I'm going to have minus 1/2 Vx. That's the current I2. Now look, I now have this guy here. So if I look at the I prime, it should be 8 minus 4 divided by 2 plus I 8 volt. And so and that has to equal to 0. So if I clean this up a little bit, this is what I'm going to get. I'm going to get 1/2 Vx minus I 8 volt equals to 6. So now I have my equations here, right? I have my equations. So now I'm going to come in and I'm going to do this into matrix form. So now I want matrix form. And as usual, I'm going to do the same process of how do I write this? So here I go. I have V1, I have V2, Vx, I 8 volt, and then over here, I'm going to say that these are my constants. So I'm going to go look for V1. So here's my V1. So there's V1 right there. There's V1 right there. V1. And then there's 0 here. So you can see I get 1/2, 1 and 1. So I'm going to get 1/2, 1, 1, 0. So that's the start of my matrix. Now let's go to 2. So if I go to 2, I'm going to focus on 2 now. So this is 2. I have 2 right there. and that's it. So only the first two terms have V2. So therefore, I'm going to write 1/2, 2, and I'm going to go 0, 0. Now I have Vx. So for Vx, there's 0, 0. I have a Vx right there, and I have a Vx right there. So then I'm going to write those guys in. So then I have 0, 0, minus 1, 1/2. Now I'm going to go to I 8 volts, and it only occurs in the last equation. So that means here that this guy should be 0, 0, 0. And then if you look, that's got to be -1. Now let's get my constants. So you can see that the last one has a constant of 6. As I go up 3, I get 8. If I continue to go up, it's 0 and 8. So then I get 0, 8. So now we do a little bit of matrix magic. And what do I see? I get V1, which is 32 volts. I get V2, which is minus 16 volts. And then I get Vx, which is 24 volts. And then finally, I8, which is 1 amp. So these are the values that I need here, right? These are my solver equations. So now let's go find out. So I need the power. So the power of the 8-volt source should be 8I, 8V. And note that this tells me that I is 8 volts is positive. So because of that, it should be 8 times 1. And this is a positive value, which then tells me that that has to be positive 8 watts, which is this. That means that this source is a passive voltage source.